Hello.
Hello.
It's actually invisible. Okay, so I would say let's get started. A very warm welcome to everybody watching this now. Welcome to this kickoff event and welcome to the winter term 2020-2021. Very sadly, as you've already noticed for sure, this is already the second time we have to welcome you online rather than in person on an actual campus. What you see here is a Zoom meeting of our faculty. It's been streamed to the YouTube channel that you're watching. Just to explain why I'm talking, my name is Jörg Hoffmann. I'm the current Vice Dean of the faculty and the speaker of the Informatics department. Now, this job comes with a variety of responsibilities, which certainly do not normally include dealing with the implications of a pandemic. But I suppose not so many things are actually being normal these days. So this is really just to say the situation remains strange for all of us, not just you, also us. And I'm sure we're doing the best we can to keep up our high quality teaching even under those circumstances. Now, I'd like to say an especially strong welcome to those of you who are beginning their studies with us this term. So for whom this is the first time that are with you, a very warm welcome. And I am particularly feel of those of you who haven't even been able to make it to Saarbrücken, Germany yet. So it must be a really strange situation for you. We are trying to help you as best we can. That much is clear. We also have a little practice already from the summer term and this sort of thing. And one thing I can assure you of in particular is that you will not need to be here physically until the written exams. And if you cannot even make it to the written exams due to travel restrictions, then solutions will be found for those special cases like oral exams, for example. But this is quite a bit in the future. I just want to show you that you will be able to study successfully here despite the circumstances. And with this, let me show you our program for this kickoff. So I'm going to share my screen. Okay, so you see my slides now. I'm going to put them on slideshow mode. This is our program for the kickoff today. The first two items are the things we usually do in a normal kickoff. So I'm going to say a few words about the faculty. We got an extremely strong informatics side here. We are proud of this, and we hope that you are proud of being part of this. Having said that, I'm going to keep this fairly short so that we can get to the study issues quickly that certainly concern you urgently at this time. There will be a brief address by the Student Council, by your fellow students. And then Professor Jan Reinecke, who is our current Dean of Studies, is going to tackle the most general student concerns. So those concerns regarding studies that really affect all of you. And in addition, we have an offer to you to post questions in the YouTube chat. And some of us are reading this chat and will try to answer your questions. Now, a word of caution, please try to use this instrument carefully. Okay, do not spam the YouTube chat. This is not the time to post silly things. If you ask a question, there's a high chance other people have the same question. So please check whether it has already been asked. And also, of course, this is only for questions of a generic interest that might be relevant to not just you, but many of your fellow students. Your particular questions regarding your specific situation, your specific interests, you will still be able to get feedback on for the rest of this week before the term actually takes off. Okay, so this will be enough for the opening. Let me hereby officially start this kickoff in the winter term. Like I've already briefly stated, we're an extremely strong informatics set, one of the strongest in Germany. And to give you a very brief overview, at the core, of course, there's the computer science department at Saarland University. We're in a faculty together with mathematics. We have a decades-old strong connection to language science and technology. Furthermore, there are many high-ranking institutes on site. There's the DFKI, the largest German research center for AI, who have several institutes across Germany. We have 2 Max Planck institutes, which really is extraordinary, provided a piece of knowledge that there's only 3 Max Planck institutes in all of Germany that are actually to do with computer science. I'm going to skip over some things here. The most recent addition to our campus is the CISPA Helmholtz Center for Information Security, funded by the Helmholtz Society. And this is one out of just 19 such Helmholtz centers across all sciences, across all of Germany. Okay, this is us saying how great we are. Let's look at somebody else saying how great we are, and in particular concerning studies, which is your core interest. The CHE ranking is a highly reputed ranking for study quality in Germany. And to cut a long story short, what we see here are 4 key criteria for teaching quality. A green dot means excellent. And we are one out of only 4 places in all of Germany that actually has 4 green dots. Good. This is the campus, which sadly we really cannot be on these days. I'm not going to talk too much about this. I sincerely hope we will all see it for real in the near-term future. Just one point, we would actually be normally sitting in Günther Hotz's lecture hall now, which is where we have the big events and the big lectures. For the benefit of those of you who haven't even been able to make it to Saarbrücken yet, who have never seen the campus, I've got this little gimmick here. We produced a little video of the campus. I'm going to mute myself so you don't get double audio. Okay, I hope this gives you somewhat of an impression of what the campus looks like. Here are pictures of our faculty, so the professors, certainly relevant for your studies. Those 4 colleagues currently have particular roles. One of them is me, as you can certainly see. Thomas Schuster and Anselm Lammerter from mathematics, Jan Reinecke and me from informatics. And we're just particular in the sense that we currently form the dean's office. Another, of course, very important category is new faculty members that joined us during the last term. Now, Deepak Garg and Niels Vreken, I have to say to my shame, already joined us actually more than half a year ago, but I forgot to introduce them last time, and so I'm doing this now. My apologies again, Deepak and Niels. Deepak can unfortunately not be here today. He just told me to tell you he's interested in programming languages and in the design of secure systems. Yillis, however, should be here, and I would invite him to say a few words about himself now. Yillis, if you can please unmute yourself.
Okay, thank you, Jörg, and well, yeah, no worries about forgetting me. I mean, I'm still here, still around. Many of you may have already seen me because I've been walking around campus for the last 7 years already. Previously at MMCI, since 2 years or so at CISPA, and officially since a year, I'm a professor here at the university as well. My main research interests and also the courses that I teach focus on exploratory data analysis, which is just a very old-fashioned term for machine learning and data mining, where you, as a domain expert, learn something about your data. And well, you'll see my face a little bit later on when we introduce the courses, because that's one of the things that we'll be teaching in next term. So looking forward to see many of you there. Cheers.
Great. Thanks very much, Yillis. Furthermore, I have the big honor to introduce to you a new faculty member who will join us in January, Anna Maria Veit, who works on human-computer interaction. And Anna is also here. So if you can please say some words about yourself.
Hi, thanks, Jörg. Yes, I'm Anna Veit. I'm going to start in January as a professor here at Saarland University. And I'm really excited about this because I actually have also been running around the campus for several years, but this is because I studied computer science there at Saarland University, and it's really exciting for me to come back now as a professor there. My research interests are in the area of human-computer interactions. So specifically, I'm interested in understanding, modeling, and designing how people interact with computers, with smartphones, but also in virtual and augmented reality, or with virtual agents or other computing systems. And specifically, I want to use computational methods for that. So, for example, we could use integer programming to compute the best possible design for a web page that is easiest or fastest to operate. And if you're interested in optimization methods or machine learning methods and want to apply these to improve how we and everybody interact with computing systems, then you can contact me and we can discuss about doing a thesis or PhD in my new research group here.
Okay, thank you very much, Anna. This brings me to the final topic, I suppose, in my short presentation of our campus here, which is awards. Awards are, of course, a qualification of scientific quality. And now, without wanting to brag too much, we receive a whole lot of awards, best paper awards, more than we would certainly want to list in this event here. I'm only going to cover the most prestigious high-level awards here that some members of our faculty received during the last term. You already see the first one on the slide. The ERC, European Research Council, is in the meantime, I think it's fair to say, the most prestigious research grant, like third-party funding award in Europe. And we have the great honor of having two awardees during the last term, Professor Vera Demberg and Christoph Lenzen. Furthermore, beyond funded projects, of course, there are awards for long-term research impact. And arguably, I mean, I don't know how much you know about all this academic business. I mean, we have conferences each year and their papers are published and you get best paper awards. But this year, awards for more long-term achievements, like think Newton and Einstein. I mean, Newton and Einstein, of course, way up there, right? But this is the direction we're taking here. And we have, again, the great honor of having two awardees this year, Professor Christian Theobald and Professor Reinhard Wilhelm, who have been awarded for outstanding and important contributions in different areas of computer science during the last term. Finally, another kind of award that's handed out by many sub-communities of computer science are test of time and influential paper impact awards. So when scientists talk about impact, what we mean is you have managed to come up with an idea that opened new trades of thought, new possibilities for an area of science, and that inspired new research for many other colleagues. So that's what we call impact. And of course, this is the biggest thing you can achieve in science, to actually show up new roads and inspire other people to also look at these things in that way. And we have the great honor to have two awardees again, Professor Andreas Teller and Professor Gerhard Weikum. And that's it. Like I promised, we're going to keep it short and get to the studies. And the very first thing that's to be noted about studies is that we got you're already spoiled for choice. Let me say, in case it's not actually clear to you, this is very much not normal. For comparison, where I studied in Germany, okay, it's 20 years ago, but there was a single course of studies. Okay, so the amount of choice you have here is just enormous. Now, a lot of choice might, of course, also come with a lot of questions. So naturally, there's a lot of information on the web page, and also naturally, we're not leaving it at that, but providing many, many other channels by which you can contact us and clarify your questions. And in particular, about this kickoff event that we're in right now, there's going to be a web page. You just go to our main web page, and then there's a button right there on the top, information about the current term, and that will bring you to information about, among other things, this event. And this is all from my side. I will hand over to the Student Council now. Let me just close by wishing you a fun, hopefully, and very successful winter term despite the circumstances. Best of luck, and I will see you hopefully later. Bye-bye.
So thank you, Professor Hoffmann. That's Elena and me. You will see here in a bit. Sadly, I don't have a camera right now since it just broke like half an hour ago. So yeah, I'm sorry about that. Other than that, I'm Niels. I'm one of the computer science students representatives. We are the Students' Council. This basically means that we are responsible for everything going on with you on university. If you have some questions, or we represent you in almost all committees, etc. So if you have some questions regarding this, you can always come to us. But I'm not alone. Elena is not alone. We're not just two people for, as you just saw, like 2,000, more than 2,000 students. We are a lot of students. We are currently 15 elected members, most of which are situated in the courses of computer science, may it be in the bachelor's or may it be in the master's. But we also have some people that are very fond of media informatics and visual computing. But of course, still 15 people is not so much for 2,000 students, and representing those 2,000 students. And we have some other students that help us out a lot of times, and we refer to them as our volunteers, and they help us with pretty much everything that they can. And again, here, if there are questions, mathematics and computer science is represented, and furthermore, bioinformatics and some other people. If there comes a time when you see these people on campus, if this comes someday in the hopefully near future, if you see these faces, just talk to them. They're always nice and try to help you with everything that they can. So, but you, of course, cannot only just ask us some questions, but there are other things that we want to help you with as well. The first thing that we do is we have some thought protocols, so protocols from past exams. And if you have some questions concerning these, or if you need some help with exercises that you want to do for your exams, for example, you can always come to us. And vice versa, of course, we are very glad if you could help us with some thought protocols later on. So if you had some ideas and you remember some exam questions, please go ahead and talk to us somewhere in the future. Furthermore, we also have a student printer. The student printer did a lot of work for all the students in the last semesters, but of course not this summer semester, since we were not able to get to university and were not allowed in the buildings due to obvious reasons. Normally, you get 100 free copies per month per person, so you can actually copy and print quite a lot. And additionally, you can always print your thesis with us, as long as you tell us beforehand, so we can set everything up, and then we will additionally subsidize you with a little bit of money, so that your thesis printing is not that expensive. The problem with this, of course, is that you are still not really able to get to campus, and for most students, this involves just being there once a week, if even this once a week is taking place. So we came up with an idea with the faculty, or the faculty came up with this nice idea, and they included us in it. So they are currently setting up something so that we can have some time slots where people then can use different rooms. Concerning the current way the corona epidemic is going, we're not sure if it gets implemented at all, but we still hope so. And if this should be the case, that you then can come back to university and take part in some lectures or some tutorials in rooms at university, you will also get the possibility to save some time slots with the printer, which you will then be able to use to your heart's extent, but of course, just 100 free copies per month per person. If you want to reach out to us, or if you want to know what's going on with us, we always, these 3 links are all mailing lists to which you can subscribe. How you can get there, we will show you in another slide. But on these lists, we announce when we do events. For example, also when we have jobs that are sent to us by companies that want to talk to you and want to get you for their jobs. And of course, our public discussion list on which you can ask us questions, or where our meetings will be protocoled. And additionally, since this is still not that easy of a time, if you need any help, may it be study problems or orientation problems, and you're not sure what you should do or to whom you should talk, just drop us an email at help@cs.fs, and we will be sure to come back to you and talk to you and help you out with all your questions. But one simple thing with this, we are not tutors, so we may be able to help you with some of your computer science questions, but of course, we cannot guarantee that we know everything and about all of this. And with this, Elena.
So hi from me as well. Now to the more social part from the Student Council. So we don't just help you with your studies and so you can figure out your ways around uni, but we also have a lot of social events so you can get to know each other. For example, we offer breakfast or summer barbecues, winter parties, or even help with the fair like the next, where you can get in contact with companies. Unfortunately, this semester, due to the pandemic, there is not so much option. Niels, would you do me the favor and go to the next slide?
Sorry.
Thank you. Doing it live in the live stream is a bit different than doing it live. So most of our things are cancelled at the moment, but we hope that we can take them up in the coming semesters so we can at some point meet in person. One example of things that we do online now is the Next Fair, where you can get in contact with companies. So maybe save the date. It's on the 12th of November, which might be interesting for you to also see what companies are there and already get in contact with them. But also the Student Council wants to stay in contact with you. So we do have a Discord server where you can just meet other students, chat with them, chat with us. And we also offer events like online board game nights. So yeah, we try to keep up the social life as much as possible in that field. So here you can see a map where the Student Council is located. It's right above the iCoffee. And yeah, we hope to see you there at some point. Yeah, just remember that. But yeah, we're easy to find as soon as you're on campus. We're also easy to find online on social media. So as you can see, we have Discord, we have Telegram, Twitter, Instagram, Facebook. Before you now write down everything on there, on the next slide, we simply have a QR code for you to scan. This takes you to our website, and on this website, we have all the links and all the information you need to contact us and to stay in contact. So maybe feel free to take a screenshot of that and visit this website later, because otherwise we get in trouble that we all lead you away from this live stream, which is more important at the moment for you. So yeah, we hope to hear from you over any form of social media or meet you in Discord. And yeah, hopefully at some point see you at university.
The slide
Jan,
also
you're
made
muted.
available online, right, Jan?
You're muted, Jan. Jan, you are muted. We don't hear you.
All right, thank you guys. So welcome everyone. Yeah, so I can confirm we will put all the slides up on the website. So even if you didn't get to manage taking a screenshot or something, you will be available. Those slides will be available, and also the YouTube recording will be available for later watching. So I will be talking to you about the main points about the winter term, teaching in the winter term. So as you all know, unfortunately, the winter term start has been postponed. This was a global decision all across Germany that we couldn't change, but we have to live with it. So courses will start on November 2, and they will end on February 5 as originally planned. So this means that, again, the winter term is a reduced length term compared with usual semesters. And so the lecturers should take this into account when designing their courses and the material that needs to be covered. So unfortunately, due to the pandemic, we still are not able to come back to physical presence teaching. And so almost, I think actually all courses will be carried out online. The good news is that we will still be offering a full range of courses, so there's no reduction in terms of the number of courses, the breadth of courses, compared with regular terms. Now, all courses, as always, can be found in the LSF, and many of the courses that will be offered in the winter term will also be presented later on, right? So we will have individual slides and short introductions by the individual lecturers about their particular courses. Now, different courses will adopt different teaching styles and platforms. So this may range from live online lectures to recorded lectures accompanied by lecture notes. Many courses will have online tutorials. Some will have office hours. There will be forums. There will be chat rooms, etc. And depending on the course, different platforms may be used. The individual course websites will give you much more detail about what is done in a particular course. Okay, so one important information for international students is when will you be required to be on campus, right? So, and the good news for you guys, if, you know, I'm sure it might be difficult actually to come to Saarbrücken, is that physical presence on campus will not be required prior to the exams. And we have the commitment of the, you know, all of the lecturers to enable online participation throughout the term. Okay, so now you might be wondering, when are those exams going to take place? And as usual, our exams will start the week after the end of the lecture period. And so this year, or rather next year, that's going to be February 8th. And so all the end of term exams and also the re-exams for the winter term will be carried out from February 8th onwards. Now, some exceptions may be possible if there are good reasons. In particular, this might be midterms for basic courses, but this is something that should not be a concern for international students in the master's program. Again, detailed information will and can be found on the respective course websites. Okay, exams and exam inspections. So this was obviously not so obvious last term, but in the meantime, we figured out how to deal with the pandemic, also in terms of exams, written exams and oral exams. And so as of now, written exams on the campus are possible as in the summer term. And for this, sufficient space will be provided and hygiene measures will be adopted. We strongly request participants to wear a face mask during exams to make sure people stay safe. Okay, so again, exam inspections, it's the same story. The same rules will apply for written exams. We can carry them out and we will try to make sure that we do this in the safest possible way. Okay, so further information on the term and things that might come in later during the term, you can always find them on the Saarland Informatics campus page. And there we will also post answers to questions that might come up during this event that we're not able to answer right away. And so if you do have questions, please feel free to post them in the chat in the YouTube channel, and we'll be trying to answer them. And if we're not able to answer them now, as I said, we will try to post the question and also the answer on the page that I just showed. Okay, so let's see.
Jan, I think you're not
Yes.
sharing your slides.
Yes, I just saw the chat. I'm very sorry. We will put up the slides. I guess it doesn't make sense to go through them again now, does it? I mean, I will share the slides with all the dates on the website. I'm sorry for that. Okay, Tanya and all, are there any questions that we should be answering? So this would be the time, if you have questions, post them in the chat and we'll try to answer them either now or later on. Okay, let me have a see. So let me have a look. So is the Prog 1 midterm exam planned to take place on campus? So I guess this is a question we'll try to answer on the website later on. I don't have the particular answer for you. Yes, there will be Christmas holidays. Those are, again, we will post this, but this is a 2-week holiday around Christmas. Okay, I suggest we continue collecting the questions in the chat, and then we will collect those questions and the answers to those questions and post them on the Saarland Informatics site. Okay, so sorry for not sharing the slides there, but let's move on, and let's move on to the course presentation, which is really the center of this event. So I hope you can all see the slides that I'm sharing now. Yes?
Yes, we can.
All right, perfect. Okay, so so one thing to keep in mind before we go into the presentation of all the courses is the following, and that is that the status of different courses, like whether it's a core lecture or whether it's an advanced lecture, may differ between different degree programs. So if you're a computer science student, or if you're a DSAI student or a cybersecurity student, a particular course may have a different status depending on which degree program you're in. And so it's important to know, of course, when you're taking a particular course, what status it has, because you have to take a certain number of courses of each type. And so for that, it's important that, you know, if you go to the LSF, if you go to the course catalog, you can check for your study program which courses you may take and which status they will have. This is just to avoid some confusion, because people might announce their course as a core lecture or as an advanced course, and then your degree program is different. And so then you might be in trouble because you're not fulfilling the requirements for your program. Okay, another reminder before coming to the course presentations is that we also have, and this is new this term, we have so-called teaser videos where lecturers give around 2-minute presentation about their particular course, and they can go into a little bit more detail, and they can go here during this short presentations that we have right here. And so you can find those if you go to the Saarland Informatics campus YouTube channel. There is this lecture teaser section with all those teaser videos. Okay, and so that brings us to the course presentations, and for this we will go in alphabetical order according to the last names of the lecturers. And according to this, Karl Bringmann is the first to present his courses, and he's going to be teaching algorithms and data structures. Karl, can you please introduce your course?
Yes, hello, I hope you can hear me. I'm presenting algorithms and data structures, the core lecture. So this is the core courseway that will prepare you for all the advanced courses in theoretical computer science, meaning that you learn about fundamental algorithmic problems and how to design and analyze efficient algorithms for them, and in general algorithmic problem-solving techniques. So the topics range, there's a broad range of problem areas like graphs, strings, polynomials, and geometric objects like points and lines. A big part of the lecture is on randomization, how to exploit randomness, how to analyze it. And another big part is on amortized analysis and how to use it to design some advanced data structures. Lecture will happen on Tuesdays and Fridays from 10 to 12 on Zoom, and I'm giving it together with Marvin Kühnemann from Max Planck Institute. The requirement is that you have heard some introductory course on algorithm design and analysis, such as Grundzüge von Algorithmen in Datenstruktur. All right.
All right, thank you. Okay, so next up, this is maybe confusing, but actually Karl will also present a course offered by Peter.
Right, let me also talk about this course offered by Peter Clare. This is Topics in Algorithmic Game Theory and Economics. Algorithmic game theory is a field at the intersection of theoretical computer science and game theory. This is about games, equilibria in games. Think about market situations like where you want to sell advertisements online, or you want to connect kidney donors to patients that need kidney transplants. So these kinds of market situations require game theory to understand them, and algorithmic game theory has all kinds of algorithms in that area. That's an advanced lecture happening on Wednesdays from 2 to 4. Now, why am I presenting this? Because the lecturer is currently in hospital. It's actually not true that the first lecture will be on November 4, like it's written here, but it will be postponed to November 11. And well, Peter is optimistic that until then he's back on track and can give the lecture. All right.
All right, thank you. Okay, next up is Vera Demberg. Vera, can you please tell us about your statistics with R?
Hello, everybody. So I will be teaching the Statistics with R course. This is going to be focusing on how to do hypothesis testing. The contents of the course, the contents of the course will be about exploratory data analysis and experimental design. A large part of the course will be on hypothesis testing. We will start out with very simple things such as the t-test and chi-square test, and then move up all the way to linear mixed effects models. Of course, one important point of the course will be on, what are common things that are done incorrectly, such as multiple testing that's illustrated in this comic here. The lecture will take place on Tuesdays from 8:30 to 10 in Microsoft Teams. So if you want to take part in this course, please find the course webpage, and there's a link where you should already join the course now. Further information is also given there. Tutorials will also take place. So there's 2 slots in the week for this course, and the tutorial slots will still be doodled. One of them will certainly be on Wednesday morning, 8:30 to 10.
Thank you. So Jens Dittrich, tell us about database systems.
So unfortunately, Jens could not take the presentation himself. He had to leave. So I will take over. My name is Christian Schön. I will be the teaching assistant for the database systems course. This will be a core lecture, essentially a follow-up lecture to the big data engineering course, which some of you might already have heard in the last terms. We will dig a bit deeper into questions such as how to manage large amounts of data, which storage devices to use, how to access them, how to query data and how to optimize such queries, and so on. So all about databases and data management. We will have a practical project within this lecture. So you should bring some programming experience, preferably in C++. The first lecture will be next Wednesday, so next week, Wednesday at noon via YouTube. And we will have additionally a lab on Friday. All further information and the links will be published via our website, which you can find here at the top.
All right, thank you. So next up is Mario Fritz. Mario Fritz will be teaching machine learning and cybersecurity. Please let us know about your course.
Yeah, hello, also welcome from my side. I'm teaching this advanced lecture, and you probably have realized how strong progress machine learning has made in the past years. And in this lecture, we're looking at how this success carries over to applications in security and also privacy. So we'll look at applications to malware classification and phishing detection. But as we use those techniques in these critical and sensitive environments, we also have to be aware about risks and potential attacks on machine learning. So we'll also look what attacks exist and how we can defend against them, for example, also in terms of reverse engineering of those models. Also completely new risks emerge like privacy leakage, or also, as you have recently probably seen, deep fakes that try to mimic reality in a very convincing way. The lecture will be taking place Thursday from 4 to 6. We also have an exercise with practical assignments where we train and attack deep learning models. And we also have a project phase where you can realize your own projects. For more information, please visit the website below.
Thank you, Mario. So Sebastian Hack. Sebastian, you will be teaching compiler construction. Tell us.
Yeah, thank you, Jan. Hi, everybody. So I'm teaching the compilers course this winter. And yeah, compilers are really a core component of our computing infrastructure. They are almost everywhere. They're in browsers, graphics drivers, databases, network stacks, machine learning frameworks, and so on. So by learning about compilers, you learn a lot about what programs actually are and how you analyze them and how you transform them. So this knowledge is not only fundamental for building compilers, but also for various other disciplines like software engineering, security, high-performance computing, and so on. So knowing about compilers will also influence your programming. Understanding what happens to your program when you give it to the compiler, you will also have a much better understanding of what actually happens when you execute it. So this makes you more conscious and perhaps even a better programmer. In the course, we'll cover the foundations of syntax analysis, program analysis, code optimization, code generation, and we'll also look into more advanced topics like polyhedral compilation and domain-specific languages. Last but not least, the course comes with a programming project where you implement a non-trivial compilers in small groups using LLVM, which is a top-notch compiler framework that is widely used in industry and academia. So I'm looking forward to seeing you in class.
Thanks, Sebastian. So next up is Thorsten Herfit.
Yes, hello everyone. Thank you, Jan. Besides the seminars, bachelor and master seminars, we will be giving 2 courses this semester on the fundamentals of digital transmission and signal processing, and later on multimedia transport. Both courses, even though it's telecommunications, meanwhile, are core courses in informatics. Every one of you knows that systems like 5G or Wi-Fi really are based on telecommunication knowledge. We will do the courses live. Digital transmission and signal processing will be done Tuesdays 12:15 to 1:45 and Wednesdays 8:30 to 10. Of course, the lectures will be recorded and made available to all the students in class, but nevertheless, we'll guarantee a closed classroom. So the videos will not be streamed over YouTube, but will be made available to the class. On the tool side, we will use MS Teams for the live lectures, and we'll do weekly quizzes and assignments that are also visible at certain predefined time slots, so that the overall lecture will be 100% paperless. There'll not be a midterm exam. Nevertheless, we consider to, in a later part, when it would be possible, to have 1 or 2 presence meetings so that we can get to know each other also in person. DTSP will deal with all major blocks of modern telecommunication systems, so discretization, digital modulation, multi-carrier transmission, and many others, and the underlying mathematical foundations. Registration, bold and red, registration is mandatory. So please, if you want to participate, register in Moodle. The Moodle site is given, but if you just enter Moodle and look for the telecommunications lab, you find it. And I've just checked already more than 30 students have registered. Hope to welcome many more of you. Next slide, please. Yeah, and that's now multimedia transport. After we have done all the basics, we'll look from the IP layer upward. So IP layer, transport layer, application layer, session layer, and so on, with a focus on multimedia networks. It's also a core lecture in many study programs, an advanced lecture in the others. And the course will use the same toolset, MS Teams, Moodle for quizzes and assignments. It will run Tuesdays 2:15 to 3:45 and Wednesdays 12:15 to 1:45. Both courses, I forgot to say for the DTSP course, will start next week, so on November 3rd. In multimedia transport, we'll deal with all major components of multimedia streaming. So latency resilience, awareness, congestion and flow control, adaptive and hybrid, ARQ, so error coding, and again, the underlying mathematical foundations. Registration in the same way as before. And if you want to look at some teasers, go to our webpage, and then you'll also see how the tools will be used throughout the lecture. So I hope to welcome many of you next week on November 3rd and November 4th. Thank you.
Thank you, Torsten. So next up is Jörg Hoffmann. Jörg, you will be teaching AI planning, as I can see here.
That's what I'll be doing. And the slide is animated, so please watch out for when I say click. Okay. Okay, so what is AI planning? That's a sub-area of AI, and some people claim it's the art and practice of thinking before acting. I usually prefer a more a down-to-earth manner of defining it. Click. Namely, it's about the reachability problem in compactly described large transition systems. When I say large, I mean large. Billions is like a small comparatively. Number of atoms in the universe would be like really large. The problem definition, nevertheless, is pretty simple. You start in an initial state of some system. It can be a single-player game. It could be a robot. It could be pretty much anything. It's very generic. You have some goal condition that you want to reach. You have a set of actions. You want to find a sequence of actions that takes you to the goal. The problem is you don't want to look at 100 billion states in order to find the solution, or you cannot due to time and memory requirements. And therefore, click. You need to use more clever search techniques. And that's really what this course is about. It gives you a very comprehensive overview of the use of heuristic search in the field of AI planning. This method has revolutionized the field of AI planning and dominated it for the last 20 years. And you're going to see all the relevant methods and also interesting theoretical properties about them. Now, I don't know if you're that much into theory. However, click. I'm not giving you much time, Jan, am I? The main focus of the course really is more practical. There are programming exercises in which you'll be implementing your own planning system, starting from the code base we provide. And at the end of the term, we're actually crowning this, click, with a student planning competition. So there's a competition between the systems that the students have built, and they're basically running the systems on a set of benchmarks and measuring time. What you see here is actually the actual outcome of a student competition from one of the previous years. I've usually even provided a little prize for the winners, so I'm not really sure it'll be possible in this term. Anyway, if this is interesting enough for you to invest 3 minutes, then you can look at the 3-minute teaser on our webpage. And that's it from my side. Thank you.
All right, thank you, Jörg. All right, so next up is Antoine Zhu. He will be teaching algorithms for cryptanalysis. Antoine, please tell us about your course.
So first, I have a short announcement. Sven Jacob asked me to tell that his course on parameterized verification is being postponed to the summer semester. So coming back to my lecture on algorithm for cryptanalysis, so basically the context is the following. Whenever you want to do cryptography, in the modern day to protect whatever you are doing on your computer, you are relying on problems which should be difficult to solve. So what we are going to do in this lecture, we are going to look at this difficult to solve problem, and we are going to see how they can be attacked, either by doing mathematics and finding ways to break the core problem, or by looking at the ways they are used in crypto system, and by finding flaws and loopholes in the thing in order to attack them. So in order to go to this course, you need to have quite a good knowledge on algorithms. And you have more details on the webpage, which is there. The course will be taking place on Friday in the afternoon from 2 to 4. It will be a live lecture on Zoom. And at the end of the lecture, you should be able to do some of your own project on cryptanalysis, and I will have you program some of these important algorithmic and mathematical idea in order to give you the marks for the project. And basically that's it. So you can see the shape of the thing here. We will be talking a little bit about elliptic curve, even if it's not written. It's kind of implicit. And that's it.
All right, thank you. So Dietrich Schlacko will be teaching neural networks. Dietrich, are you there? Can you tell us?
Hello, everybody. Unfortunately, Professor Klakov was not able to attend, so I will present the course. My name is Ali Dawoodi. I'm the master tutor of this course, Neural Networks, Theory and Application. So in this course, you will be get familiar with the basics of neural networks and also the recent advances in deep learning. So the topics that we cover in this course are like we start with like introduction to machine learning, like linear regression, PCA, and so on. Then we move on with deep forward networks, backpropagation algorithm, and so on. And then we discuss regularization for deep learning, optimization, how to train deep neural networks, and also what is the state of the art for the optimization. We also covered convolutional networks for computer vision and as well as natural language processing, and we end with the course with sequential models, recurrent networks, LSTM cells, and so on. You can get more information about this course on the web page of the course, and of course it will be virtual. We start next week using MS Teams. Yeah.
All right, thank you.
Okay, yeah.
Course, are you going to present that one as well?
Yeah, so there is also another course, signal processing. The topics that we cover in this course are like representation of the signals, the video, voice, and so on, and then system theory, a bit of system theory, linear systems, Fourier transform, the application of Fourier transform for signal processing. Then we moved on fast Fourier transform and numerical methods for Fourier transform, and the correlation of the signals, how to measure the closeness of the signals, and so on. Also we discuss a bit about statistical aspects of signal processing, and we end up with filter methods. Yeah, you can also get more information on the course homepage. Yeah.
Okay, thank you. So Jana Köhler is offering architectural thinking for intelligent systems. Please let us know more about this course.
Yeah, hi everybody. Architectural thinking for intelligent systems teaches established methods how we can build a good architecture. So given any software architect or software system that we want to build, the question is how can we arrive at an architecture that makes the system actually a good system? And we'll learn about established methods that are used by modern software and architects to build such systems. We practice these methods on an AI project. Since my background is on building such systems, we'll also use an AI project this semester. It will be a robot project. The focus of this lecture is on systematic conceptual thinking, not on coding, not on proofs. So here we want to master the language and the methods that are used in software architecture. And the course also provides a very first foundation to prepare later on for professional architecture certifications. The course is run via the official university Teams platform. To participate in the course, please register at the Moodle platform. You find all the information there. Quite a number of people have already registered. Once you're registered in Moodle, then you will also be added to the lecture team. And the lecture takes place on Thursdays, 10 to 12. And but it will also be recorded, and all material is available online. Thank you.
All right, thank you. So Robert Künnemann. Yeah, it's actually a team teaching this course. Who's going to present this one?
Yeah, it's me.
All right, please go ahead.
All right, let me quickly describe to you the concept of this advanced lecture, Formal Methods in Security. Formal methods in security provide you with the tools to argue the security of a system with mathematical precision. They also give you a systematic way to find attacks and even some automation. And in this lecture, you will learn various techniques that apply at different layers of the system. This is the reason why it's split among 3 people. Hamid Nemati will present techniques that apply to the foundation of everything, that is the system level. Marco Vasenna will introduce information flow control techniques at the language level. which can ensure that the information flow within a program adheres to confidentiality and integrity requirements. These programs communicate, and protocols guide how they communicate with each other. So in the third part, I will introduce methods that focus on the communication protocols that these programs follow. Yes, if you seek further details, please visit the link on the slide. The introductory lecture, let me just mention this, takes place tomorrow at 10, and we would be very happy to see you there and give you an overview of what we will be doing in this course. Thank you.
All right, thank you. So Giancarlo and Niels, you're both teaching the security course. Who's going to present this one?
Yes, it's me. So hi everybody, I'm Giancarlo Pellegrino, and together with Nils Tippenhauer, we will be teaching security, which is a security lecture of 9 credit points. So the lecture will provide a comprehensive introduction to all facets of security and privacy, like system security, web security, cryptography, software security, and much more. One of the reasons why you want to attend this lecture, or maybe even you don't want to attend this lecture, is because there will be plenty of hands-on exercises, including a mini capture the flag competition at the end of the lecture, with challenges that are written by the students. So the lecture starts next week on Tuesday and Thursday. If you want to know more, please visit our link on the slide. That is our CMS hosted by CISPA. Thank you.
Thank you. Okay, next up is actually myself. So I'll be offering a course on program analysis. So what is program analysis about? So you may all know one famous program analysis question, and that is the halting problem. So given a program and an input, the question is the program going to ever terminate or not? And if you've taken some basic theory courses, you will know that this problem is unfortunately undecidable, right? So it's impossible to solve this seemingly simple program analysis task. And this actually generalizes to any kind of interesting question you might have about a program. Right? So if you want to know, does this program terminate on all inputs? Does this program ever crash? Is this program ever going to leak sensitive information? Is my program going to terminate within a certain time bound because maybe it's used as an airbag controller or in some other time critical setting? All these problems, unfortunately, are not solvable in full generality. Nevertheless, there's a rich theory and also practice of program analysis techniques, which are, due to this undecidability nature, approximative in nature. So in this course, we're going to discuss fundamental techniques in program analysis. So this includes in particular data flow analysis, abstract interpretation, and symbolic execution. And we're going to also see how to apply such techniques to prove the absence of runtime errors, to analyze programs with respect to side channel vulnerabilities, and also to analyze programs with respect to real-time systems guarantees. So this course is going to take place Tuesdays and Fridays, each time from 12 to 14. It's going to be done fully virtually, most likely using MS Teams. Further details will be provided on our website, also links to the first lecture, which is going to take place next Tuesday. So hope to see you there, and let's move on. And the next speaker is going to be Frank Olaf Schreier, who will be, no, this cannot be right. I'm very sorry for this. Let's see, so shall we, this is terrible. I've been provided these slides. I'm sorry, maybe Philip can present this course, and I hope when we get to Frank's course, I can call you back. I'm sorry. Philip Slusalek, can you please present the computer graphics course? Philip, are you around? So if not,
sorry, I am around. I am around. I was still
right.
Because I wasn't
sure.
expecting to be called at this point.
Yes.
So no, I'm not Frank Olaf Schreier, Philipp Susalek here. I'm teaching so I'm have the chair for computer graphics. So we're teaching the core course on computer graphics, or CG for short. It will give you a broad overview of most of the computer graphics technologies that are around, starting actually from ray tracing, which used to be a little bit exotic for a lot of time, but actually will or is about to become widely used. It's already in every NVIDIA graphics card with hardware acceleration. It will be in all the Intel and AMD graphics cards and maybe others as well. This is actually the best way to teach computer graphics. We've been doing this for 20 years, and now we actually get the hardware support for that. We'll also talk about the human visual system. We'll talk about sampling techniques and textures and material models and light transport, transformations, and many, many other techniques. Of course, we will also cover OpenGL or rasterization APIs towards the end of the lecture. And so you really get a broad overview. You will actually, during the course of the lecture, you will actually build your own personal ray tracer. So during each weekly exercise, you'll add more and more to it. And towards the end of the lecture, we also have a rendering competition. And at the bottom of the slide, you see some of the examples of the images that some of your fellow students have created over the years. So you see, you can do amazing stuff with that. And it's a lot of fun to do this. You actually do this in small groups. The lecture itself on Mondays afternoon and Thursday mornings, because Monday there's usually a lot of stuff happening. So we're actually starting next week, Thursday, 8:15. It will be online, a live lecture via Zoom. It will also be recorded. If you have any questions, either email me at the address here or just go to our webpage, just searching for my name leads you to our web pages, and there's a lot more information on the course there. I'm happy to see you there next week, and it will be a lot of fun doing this together. Thank you.
All right, thank you. So I double checked, Frank, and unfortunately we don't have your slide in this deck. Maybe you can still tell us a few words about the course that you will be teaching.
Yes, so I'm giving a core course, Computer Algebra and Gröbner Basis. The basic goal is to decide how to solve algebraic polynomial system of equations. And if we know that there's a solution, we might ask how many solutions there are, what is the dimension of the solution space, and so on. So this is in my field of expertise, algebraic geometry and computer algebra. And then I have a second course, which is a seminar on quantum computing, in which area I'm an amateur. This will be a seminar run as a reading course, which I think is more appropriate for online teaching. So the students will not give talks, but we will discuss. The textbook is Quantum Computation and Quantum Information by Michael Nielsen, Isaac Chung. And if you're lucky, at the end of the term, we understand why Shor's algorithm works. Thank you.
All right, thank you, and apologies again about the slide mess up. Okay, so next up is Isabel Valera. Isabel, tell us about your probabilistic machine learning course, please.
Hi, so this semester I will be teaching an advanced lecture on probabilistic machine learning, and in particular I will be introducing you to the probabilistic modeling pipeline, which I represent here with this figure, where we will see how to deal with real-world data, how to design generative models for this data, and how to learn the parameters of this model. So for that, we will have one lecture every week on Wednesday, where I will introduce to all the theory of the probabilistic pipeline that then we will put in practice every Monday by programming these algorithms and analyzing this data. So if you want more information, down in the corner, left corner, there is the website where you can register and access the material of the course.
All right, thank you. And there's actually another course that Isabel is co-teaching with Phyllis. Phyllis, are you presenting?
I'm presenting. I mean, at least I will kick this off. But well, what separates alchemy from science is knowing, well, having some thorough knowledge about the elements of what you're dealing with. So if you want to speak about nature, you have the traditional 4 or 5 elements, right? Fire, water, and all that good stuff. If you're talking about chemistry, I mean, currently the counter is at 118 elements that you need to study. But in all around us in media and whatnot, you hear about AI and machine learning. And if we don't want to do alchemy, but actually science on machine learning, we need to know what are these basic ingredients. And that is exactly what is going to be the topic of this course. I'll be teaching one half, and the second half, or actually the other way around, I'll be teaching the second half, but the first half will be taught by Professor Valera, who will explain the next part. Isabel?
So I was muted here. So starting next week, we will start introducing you to the elements of machine learning. Every lecture will be in Zoom, and we will also live streaming in YouTube. The records will remain there so that you can watch it afterwards. And there will be some assignments throughout the course that you will need to work on and provide the assignments so that you can at the end take part in the exam. And I will see you next Thursday.
All right, thank you. Okay, now comes a group of courses presented by Joachim Weikert.
Yeah, hello everybody. My name is Joachim Weikert. I'm heading the Mathematical Image Analysis group. And this semester, our group will offer you 4 classes and 1 seminar. I'm only going to present 1 class. The other 3 classes are presented by the lecturers themselves. All our classes have 2 things in common. First of all, our chair belongs to both math and computer science, and therefore the lectures either count as a computer science lecture, or in case you are a computer scientist with math as a minor, you can also use it as a math class. Secondly, we assume that you have some sort of undergraduate math knowledge, something like mathematics for computer scientists 1 to 3, so the typical math that is taught here in Saarbrücken. The lecture which I am offering this semester has the somewhat scary title, Differential Equations in Image Processing and Computer Vision. Nevertheless, it has received 4 teaching awards, so it can't be all that bad, probably. It's an advanced class. You don't need to know anything about image analysis. Also, it is helpful, of course. Basically, the scope of the lecture is to look at methods which are model-based, which are using differential equations as models. And these are mathematically very well understood techniques which can be used, for instance, to remove noise from an image, to restore an image, to segment it into semantically meaningful parts, to analyze motion in videos, or to come up with novel methods for data compression. And what you see here is an example where we have basically used an osmosis process from nature in order to remove the shadow from an image. So you can actually reinterpret certain things from nature in order to improve your image analysis tools. On top of that, you have an extra benefit by attending this lecture. So this is the lecture which is required if you would like to write a master thesis in our group. As I said, you should know some undergraduate math and a little bit of very elementary C programming for the programming assignments. The lectures are Zoom lectures, live Zoom lectures, which take place Monday and Friday from 10 to 12. We start already next Monday, November the 2nd, and at the bottom line, you can find the website where you will find more information about registration and everything. So thanks very much. And I'm now handing over to Pascal, who will present 2 lectures.
Yeah, thank you, Joachim, for the introduction. As you said, I offer 2 lectures. The first one is the image acquisition methods, which only has 2 teaching awards, but still I think the lecture is pretty okay. And this lecture intends to teach you where images come from and what the pixel values that you see there actually represent. So also physical quantities that they might represent. And this is, of course, of particular interest if you want to do image processing, for instance, but also if you just want to understand how devices work in your everyday life. And on this slide, you actually see a few of the few examples of methods that we deal with in this lecture. On the left, there's a very early photograph, for instance. In the middle, you see some cells that have been recorded with confocal microscopy. And on the right-hand side, you see pollen images that were recorded with electron microscopy. So we really cover a very broad range of different methods here. For prerequisites, you basically only need undergraduate mathematics. Background in image processing or physics can be helpful, but really you don't need it. You will be taught everything that you need. The mode for this semester is fully digital, of course, and it is what I like to call inverted classroom light. So I already tried this last semester and it worked out pretty well. As a passive component, you will have pre-recorded videos, and this is augmented by 2 active components. So there will be live lecture discussions where you can ask questions and also online tutorials with group work. Yeah, and this same system also applies to my second lecture, which is the advanced image analysis. And here we deal with very practical methods like high dynamic range imaging, for instance, or panorama stitching that you find on your smartphones nowadays. And most approaches in this lecture actually take multiple images as an input and combine them into a single image that has somehow an enhanced quality. So the example that you see here on the slides is you have one underexposed image, one overexposed image, and in the dark areas, you cannot see details, or in the bright areas, you cannot see details. But if you combine multiple of such bad images, you can actually get one good HDR image. But this is just an example. We will also have different methods there. And this lecture also specifically aims at giving you the opportunity to implement some of these methods. So here you also need a little bit of C programming knowledge in order to try those. And I can also say it is certainly helpful here if you have already a little bit of a background in image processing or computer vision. Yeah, and in both cases, these lectures start already next week. And if you already want to know a little bit more before that, you can visit the course web pages, and I will allow you to enter the Teams groups already, where you will find a very detailed introduction video that tells you basically everything you might want to know about organization or content of the course. So would be nice to have you.
All right, thank you. And I guess the 4th course is going to be presented by Matthias Augustin, is that right? Anyone there? Maybe Joachim, do you know?
Yeah, obviously he's not here, so I will say a few words about that. This is one of the classical courses that provide some mathematical underpinnings for visual computing. So in many visual computing problems, be it in image processing or computer graphics, you have the problem that you would like to interpolate data. So that means you would like to estimate your data at locations where you have not measured them, or if you have somehow noisy data, you would like to approximate them by simple functions, such as a line, for instance. So that's a regression problem. And so this class will deal with different possibilities to interpolate and approximate such visual data. So we'll talk about splines, which are piecewise polynomials, which have smooth transition conditions. Matthias Augustin will also tell you about 2D generalizations of this concept, so-called radial basis functions, and something which is omnipresent in visual computing and also in many other areas is some least squares approximations, which actually date back to Gauss. And these are, as usual, online lectures with questions and answers, tutorial sections. We will start next Monday from 4 to 6 and Thursday from 12 to 2. So some of these slots are used for tutorials, some other slots are used for the lectures. And if you want to find more information about that, please consult the webpage below. Yeah.
All right. Thank you
very much.
Joachim. So next up is Ghalib Saeed. Can you say something about geometric modeling, please?
Yeah, so I will be teaching the geometric modeling course. It deals with 3D data. So these are ubiquitous in modern days, and they go from basic things such as fonts that are used for writing to models for cars, airplane, ships, and these are modeled. And there are also different types of data that are acquired, such as, for example, the scan of the bee model you see on the slide. So in the first part, we will try to cover the mathematical techniques for basic modeling. These involve Bézier curves, Bézier splines, B-splines, and NURBS, and so on. In the second part, we will deal with geometry processing of acquired data. So these are general meshes or point clouds, and we will see the different techniques that are used for improving these or bringing life to them, such as deformation and decoration, such as the ones that are shown on the lamp in the bottom. The course aims to provide a first-hand experience on 3D modeling, and students towards the end of the course can choose a project that they will implement of one of the techniques that are used. The course have traditionally attracted students from different backgrounds, but at the end, the majority are able to kind of implement and have good results that they are proud of at the end. So the first lecture starts on November 5th, and I will be happy to see many of you there. Thank you.
Thank you. And last but not least, Andreas Zeller has the pleasure to present automated debugging. Andreas, tell us about your course, please.
Hi, this is Andreas Zeller. Happy afternoon. Debugging is one of the most time-consuming yet least researched areas of software development. We want to do something about it, and therefore I'm going to teach you a couple of automated debugging techniques in that course. That is, interactive debuggers, checking assertions, locating failure causes, and even repairing failures automatically. I'm teaching you that as part of a sort of online book I'm currently writing with plenty of Jupyter notebooks that contain the actual techniques. And in this course, you will not only learn this, but you will actually apply this by building these as tools in a number of course projects. So if you always wanted to write a debugger yourself, this is going to be a course where you can develop lots of creativity in order to come up with the next generation of debugging tools. This takes place every Tuesday from 4 to 6, and you will find us at cms.cispa.saarland/debug.
Right, thank you, Andreas, and thank you, everyone. Thanks for sticking around, and I hope this has been a useful event to everyone. And of course, we hope to see you all for the courses throughout the term. And of course, everybody, please stay safe and have a great winter term here at Saarland Informatics campus. Bye-bye.
Bye-bye, everyone.
Bye, everyone.